Now it's time to generate HDL code from our Simulink model so we can simulate and eventually implement it on the FPGA hardware. First, return to your Simulink design and save a copy specifically for HDL generation. A good practice is to rename the model by appending HDL at the end, like this, so that we can clearly distinguish it from our simulation models. Next, we need to prepare our model for hardware. That means converting all signals from floating point to fixed point representation. In hardware, we don't use floating point. We use binary, so every signal must be quantized. For the input signal, I recommend choosing a data type like integer 32, which provides enough range for most signal processing tasks. You can set this in the block signal properties, like so. Apply the same fixed point type to all of your gain blocks to maintain consistency throughout the model. Next, open your model settings and ensure your simulation is configured for fixed step operation. We're building for real hardware timing, so choose a fixed solver. Also select discrete under solver type. Now we isolate the part of the model we want to generate code for. Click and drag a box around the relevant blocks. Right-click and create a subsystem. Be sure to name it clearly, like Convolution subsystem or Convolution HDL subsystem. With the subsystem created, you can now go back to model settings and then the HDL generation pane. Under subsystem to generate, select the one you just created. Now, choose a directory to store your generated HDL files. From experience, I recommend selecting a short, simple file path, preferably not buried deep in your project folders. That's because tools like Vivado often have trouble with a long or complex paths during synthesis. Once everything is set, click Generate. Simulink will compile your model and produce synthesizable VHDL or Verilog code, ready for import into your FPGA development environment. And there you have it. You've just taken a Simulink model and translated it into real hardware logic HDL code. In the next video, we'll bring this code into Vivado, simulate it, and test it on an actual FPGA board. If this step-by-step process helped, don't forget to like, subscribe, and drop a comment below. I love to hear what you are building. Let's keep pushing signals from theory to hardware.